Here's a question for you. If an AI like Claude is producing 10 times more code than you normally would, how do you know that it's correct? I mean really correct, not just syntactically valid, but correct in the ways that matter for your system. Does it do what you think it does? This is a genuine engineering problem, and it has a solution that's been hiding in signal processing theory since the 1940s. This has huge implications for how we should be developing with AI right now. Hi, I'm Dave Farley and welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content, hit like as well. And if you'd really like to support us, why not join us in the comments, because that helps to promote our videos to a wider audience. Thank you. Coding assistants like Claude Code can generate enormous amounts of code. But there's this principle from information theory called the Nyquist-Shannon Sampling Theorem. It tells us something important, actually something crucial. If you want to accurately represent a signal, any signal, you need to sample it at least twice as fast as the highest frequency in that signal. In other words, if things are changing rapidly, you need to check them even more rapidly. You can't check inadequately and expect to catch problems. You'll miss them. What has this got to do with coding and AI? Well, when you write code by hand, one function at a time, you get feedback naturally. You test as you go. But when AI produces an entire feature, a whole module or significant chunks of logic in seconds, you've just increased the frequency of code production dramatically. But your feedback mechanisms haven't kept up. Here's where it breaks down. Most teams will treat AI-generated code like handwritten code. They'll review it, maybe they'll do some manual testing, but they'll think, great, we've validated. But you haven't. You've done what Nyquist's theorem would call undersampling. You've introduced a change at high frequency, AI production, but you're checking it at low frequency, manual review and testing cycles. According to the theorem, you'll probably miss problems. Some of these might be serious. You'll miss errors this way. You'll see code as correct when actually it's wrong in subtle or even not so subtle ways that you didn't check. The gap between production and feedback has become your biggest vulnerability, and it's especially dangerous with AI because the code looks plausible. The mistakes are often subtle. The volume is too large to manually verify that everything still works as it did last time you checked. You can't read everything. So what's the solution? It's continuous integration. And I want to reframe how we think about that. But before we do, let me say thank you to our sponsors. We're extremely fortunate to be sponsored by EqualExperts, Transfig, and Octopus Deploy. Transfig is a financial technology company applying advanced continuous delivery techniques to deliver low latency trade routing services to some of the biggest financial institutions in the world. All these companies, though, offer products and services that are extremely well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, why don't you click on the links in the description below and check them out? I think that there's a better way to think about continuous integration. It isn't just a pipeline that runs your tests. It's not just a tool that runs your tests. Continuous integration is important because it's our most definitive sampling strategy. When you run your continuous integration pipeline on every commit, or better yet, after every significant change, you are sampling your code at the right frequency. You're checking it often enough to catch the errors that the high-frequency production creates. And if you practice continuous delivery, continuous integration's big brother, you're evaluating the definitive truth of your system after every change. Evaluating that your change is in a production releasable state. Does it do what it should? Is it configured correctly? Does the automated deployment actually work? Does data migration work? Is it safe, secure, scalable, resilient, and delivering high enough performance to satisfy your customers and users? Let me be specific about what this means with AI though. Nothing different to what it means for other forms of development. We need to know the same things before we release. So when we're building with AI, first we need to run our full test suite on every AI-generated change. Not sometime later as a batch, but every time anything changes. That means that we need fast, efficient ways of achieving that and effective ways of validating that what we got is what we want. This approach is our primary sampling mechanism. Second, we need to sample the AI's output before it ever gets into production. And I don't mean a quick code review by humans reading code. I mean automated checks, type checking on everything, linting rules that enforce our standards, architecture checks that ensure that the AI is respecting what we think are important about our system boundaries, contract tests that verify that our changes are compatible with the rest of our system. Third, and this is crucial, you need continuous integration to test for behavior, not just syntax. The AI can and will produce syntactically valid code that violates your domain logic. When you do this, when you sample frequently, you can catch problems at the Nyquist rate, the minimum at which you can catch errors reliably. If you'd like to learn more about how behavioral testing can help you with all of this, check out my free webinar on acceptance testing. This is extremely relevant to AI testing. My full ATDE course, though, includes a module on how this vital approach provides a central tool to help better structure and validate the use of artificial intelligence assistants in programming. Links to both are in the description below. So here's what this means for teams using AI assistants right now. First, don't accept large batches of AI-generated code. If you're asking the AI to write a whole feature and then you're reviewing it once, you're violating the sampling theory. Ask for and work in smaller chunks. Get feedback faster. That's going to force you to automate, and that means you can repeat the feedback every time anything else changes and get confidence that your changes are stable and are still in the software. Second, your pipeline needs to be fast. If it takes 30 minutes to run, you're not sampling at the right frequency, or you're developing too slowly. You've created latency. You need to know within seconds if the AI's change is good or not before you move on and ask it to do more. Third, make your tests the source of truth. When the AI generates code, it's the tests, not the manual review, that actually verifies that it's correct. Write tests that matter. Write tests that catch real problems. Fourth, use feature branches and integration very cautiously. I know that this is not popular to say, but when you're dealing with high-frequency AI production, long-lived branches are dangerous things. You're reducing the sampling rate again. Integrate frequently. Keep your team in synchronization. Fifth, invest in your deployment pipeline, because once your code passes continuous integration sampling, you need to get it into production. That's where you get the real-world feedback signal. Your system in the wild is your ultimate sampling mechanism. Here's what's actually happening. We're not just writing code differently. AI is changing the fundamental dynamics of software development. In the past, we had a bottleneck, the developer's speed of typing. Everything moved at the pace of human thought and human fingers. Now, that bottleneck's gone. Code can be produced faster than humans can reason about it. That's not a problem. It's actually a good thing, as long as we can help use AI to help make us more productive. But it requires a different kind of discipline to make that change effectively, one that those of us addicted to continuous delivery have been learning for some time now. It requires that we understand feedback as a first-class engineering concern. The Nyquist-Shannon Theorem is telling us if you increase production frequency, you must increase feedback frequency, or your system will fail. Continuous integration isn't just a nice practice when you're working with AI, it's a fundamental requirement. It's realistically the only way to ensure that we actually understand what's being built. So the next time you're working with Claude Code or any other AI assistant, remember, you're not just writing code faster, you're changing the signal processing characteristics of your development process. Make sure you're sampling the output fast enough to catch the errors. Use continuous integration as your sampling mechanism and trust the maths. Thank you very much for watching. And if you found this helpful, please do subscribe and let us know in the comments how you're using AI with assisted development. If you'd like to support our channel further, why not consider joining our Patreon community? And to our existing patrons, thank you very much as ever for your ongoing assistance. It's very welcome. Thank you.